this video I want to show you how to assemble and calibrate a W3. It's pretty simple, but there's some tricks, and doing it right and doing it carefully will make it last longer and also work better. So over here are the parts we got: the box, the sensors, and the circuit board. You can see that the sensors I've already assembled. One thing you probably want to do on this is when you screw these parts together, use a bit of super glue or a thread locker. Thread locker is the best stuff because they will work loose, just from vibrations and moving around and like that. So let's start by soldering up the board. And what I do usually is put another one of those so it lays flat. And we'll just tin these. I'll first put on my reading glasses. And you want to tin these. This will be a lot easier when you get ready to hook up the wires, to have them pre-tinned. Now don't overdo it, and try to do a nice job soldering. It is an acquired skill. You can see I'm sort of shaky, which I inherited from my mother. But then you want to also be sort of organized here. So what I'm doing is putting them crosswise like this, and they go red, white, green, black. So it's almost like the colors of the flag, red, white, blue, but it's red, white, green, which is actually the colors of the Hungarian flag, according to Alexa. Okay, and you want to get those, and because it's going in this box, you want to do them coming in like that. So now I'm right-handed, so it's a little easier to do it this direction. And I spread those wires out, hold them like that, and it makes it pretty easy. After doing hundreds of these. And there's no need to run the wires through the little holes. That's just to connect the top to the bottom pads. Soldering them on like this will be just fine. They'll last very well. Okay, now let's do the other side, which is a little bit awkward. And also, keeping these wires sort of organized just makes it a little bit easier when you go to seal it. Okay, so this is the harder one for me. Guess I'll do black first because it sort of gets to the right place. Green. And if you get the wires out of order, it won't calibrate right. And something that I do all the time. Oops, okay. Come on, get on there. There we go. Okay, that looks good. And that's this one, that's that one. This is that one. And we'll put it through the hole that we pre-drilled. You saw in the instructions for that. And that hole, when you mount it on your hive, you want to be down just so that it doesn't bring water in. The hardest thing on all these beehive electronics is the weather. Well, and the bees. For the sensors inside. The bees, it's a humid environment and they're bringing in a lot of junk, and if you treat with some of the more aggressive acids, that can be hard on things. Okay, so I've got all those soldered. Now I'm going to carefully pull those back, and you can see it fits in there very nicely, and those wires come out like that. I'm going to go ahead and put my hold down screws in it. So these little short guys are the ones for that. Okay, now we got that in there. Now let's put on the tape to seal it. And you may have a better way, but I'll show you what we've come up with here. Again, what can happen is the water might wick up the wires. And so we put this on like that, because we want to seal both sides of the wire, but we want them to come out of the hole correctly. Okay. Let me put this on here like that, and then I'll cut a piece. That goes partway over these other two guys. And you can see then I'm laying the wires flat. Well, don't pull them too tight, because you will break the wires and the connections. They're quite robust when they're like this, but in certain stages. Then what you want to do is be sure to seal around the edges of that hole, and then up like this. So it shows a little differently in the manual, but this is what I'm in love with right now. So we are all assembled, and now we want to calibrate. So we'll go over here, and the most important thing about the calibration, it'll work really well if all 4 sensors have even support. So what I've done, because I'm doing a lot of these, is take 2 boards and put my mounts on there. And the board's really flat, and then I use a board on top when I put the weight, which is also very flat. If they aren't flat, and if you are calibrating and wiggling around, it's not going to calibrate quite as well. And we'll see that as we go into the calibration. So let's take a couple of batteries. Let's start this up. When I'm putting in the batteries, I usually put in this one first, push it to the end, and then put in this one and spring it back. I can't find any better battery holders, but I mean, they work good, but they're a little bit wonky. Okay, my 4 sensors are in here. I should be running, so I'll come over here. And here's the PC program. And the PC program, we make no apologies for. We've used it for a lot of years. It's a little bit twitchy. It works really well, once you get the rhythm of it and everything. And we use it for a lot of different reasons. So you can see it came up here, 49026A. This line is telling you the firmware version, well, the model number, the firmware version, battery level, the number of samples it's taken, the temperature. If the temperature is wrong, then something's wrong with the board. The humidity, which is 0, because we don't have a humidity sensor on here, and the weight. Since it's non-calibrated, it's showing minus 60 pounds, which isn't unusual. Now what we'll do is we'll go to calibrate the weight, and you'll see down here at the bottom, it tells you the connection status. It tells you that it found the Bluetooth module on COM3 in this case. It looks for that automatically. And then it looks for whatever device is listed in this window down in the lower left-hand corner, device to connect to. Once it's connected, then you'll see it come up, and you'll see it give the status up here in the right-hand corner, and the values that it reads down in the lower right-hand corner. Okay, so now we're going to hit Cal W2 up here at the top, that button, and it's going to do a 0 reading. So it's changing its mode so that instead of reading pounds, it's reading the binary values out of the sensors. And you can see here in the top row, now it's read them. It waits for everything to stabilize, and it knows what 0 is now. The rest of the display, let me put this here. Okay, so the rest of the display, the next 9 lines are as it's doing its calibration sequence. They'll go down automatically if you use something like a 30-pound weight, 30 or 50-pound weight. It'll go through automatically. If it doesn't, you can push the button over here on the right-hand side that says grab. And it doesn't matter what order you do them. When you have all the 0 and the left front, right, left rear, right front, when you have values for that, then if you're doing it manually, you can say calculate W2, and it'll calculate the offset and the slope for all the different sensor values. And then you can say update W2, and it will save it. Now what you'll see me do, it does all automatically because we set it up so that we could do a lot of these, and it will look, so as you look down the list here, offset and slope aren't calculated yet. In that case, we use a default value that we know is close, just so that we can see that things are basically working. You know, it's just a standard value for each of the sensors. And what that lets us do is see the zeroed values below in the binary, in the decimal, but in the units of the A to D converter. The delta is from one sample to the next. Delta is telling you how much it changes. So you see, as I just go through this a little bit. Okay, if I let it stabilize, then they all go, they can fall in values. And you can see if I push the left front here over on the left side, it went up to 318,000, minus 318,000, then it came back up. As I let go, it's coming back up. We use that so that we don't collect calibration values unless it's really stable. So as things settle down and the sensors, you can see they all go clear, and now it will collect a value. The scaling of these is basically, you can see in the line below, like 116 was 0.071 pounds. So they're really accurate A to D conversion and all that. So we wait for it to be under 200, either plus or minus 200, and then we collect the values in the automatic mode here. So we've got 0. I know that the weight of my board and the weight of my 33-pound tractor weight, I think it is, came from Dwayne Kaufman, is 40.85 pounds. I measured that a bunch of different ways, and now we put it over the left front. And you can see the zeroed value came up to 26.5 pounds on that one, and the other ones have some weight on them too. And what we do is the software looks for that to be, I think, over 20 pounds, and then it says, oh, okay, as soon as it's stable, collect it. Then I move it back to the left rear, and if you watch the left rear values, it went to 26. And as soon as those delta values aren't green or red, okay, so they're all under 200. Now I go back to here, and same thing, you see them get really big, but then settle down pretty quickly. And as soon as they all go clear, it'll automatically grab it. Like I said, you could push the grab button up beside that row. But because we're doing these and moving all around, we like it to work automatically. And don't wiggle around too much, or it does. Now, if it never settles down, then you've got an electrical problem and something isn't working right. Okay, and we do the last one here for calibration, the right front. And once it gets the right front, it'll calculate automatically the offset and slope, and you'll see those. And every time it does this, it's writing the results to the file that's down in the lower right-hand corner. So you can see this one is 49026, and the date, and then the time, .csv. Okay, so now it's saying move to the left. So after we calibrate based on the four corners, then we do a test by basically putting it on the sides, which is telling us that these two sensors are calibrated right. And before you do all this, you can see on the real weight, I entered the real weight, which is 40.85, like I said, I measured. And then after it does calibration, it's saying, okay, if we're within, I think it's half a pound, 0.2 pounds, I don't remember. If it's within that of 40.85, oh, I gotta move back to the right, then it will highlight it green. If it's off, it highlights it red, which is again just something we do for our production to make it easy for our students who eventually put these together to tell whether it passes or fails. Okay, so we got, it's looking good on all those. And so it's now using the offset and the slope values, which, like I said, they're recorded also in a file, so that if we want to, if something is wonky, we can look at those and see what that is. Usually what happens is some of the wires are reversed, fix that. Every once in a while we have a bad sensor, and we can, you know, it's usually because we pulled on it too hard or something stupid like that. Okay, so now we're all calibrated, and we've proven that the values look decent. So what I'm going to do now is push update W2, and it's now going to take these values, the offset and slope for each of these, and transfer it into the flash memory of the device. And you can see it's sort of stopped doing everything, and we know it's done because it then switches it back to weight mode where it's reading in pounds, and I can see that it reads 40.68, 40.71. So everything transferred right. It's now running like it would when you put it in the apiary. At this point, you can, you know, you can move it around and see, you know, how well it does as the weight shifts between the different ones. You can take that off. It should go back to 0. You can push on them. So that completes the calibration. Okay, so then we can say new scale, and we take that out, and for us, we then put a little thing to prevent it from going on, so that in these partially assembled and calibrated ones. Now I want to show you one more thing when putting on the lid. So there again, there's a little bit of important technique. So this guy here, you want to be sure, if you look closely, you can see that one side's flat and one side's round. And you want the round side down into the channel. Seems obvious once you know that, but until you do, you can convince yourself it's wrong. Then, you know, hold this part upside down like that and put this on. That'll ensure that it doesn't fall out as you're putting it on, because until it gets squeezed in there good, it'll fall out and not seal. So once you have that, and I always use the torque rating on my setting on my drill, so I don't overdo it. And because someone taught me to do head bolts, not one after the other. I do them corner-wise. Okay, and then you have everything calibrated. You can do this after you build it into your scale. You can do it any time. But like I said, we do it and then we box it up and ship it out, and that's it. So I hope everything works good for you. You know, like I said, we've got a lot of experience with it. Using the linear algebra approach to do the calibration seems to work really well. We're happy with that. And best of luck, and you know, do a lot of these and get them on your hives and have fun. And I guess I have to end it with, remember that every hive counts.